The other type of shadow you can create is a ray traced shadow. And ray trace shadows, if you come down here to the ray trace shadow parameters, there's fewer parameters that you need to worry about with ray trace. Really, the main one is this ray bias, and that does the same thing as the bias parameter does with shadow maps. It moves the shadow towards or away from the shadow casting object, just in case you're getting leaking or it's separating too much. You can adjust that number up or down. But really, there's far less to deal with ray trace shadows, because what ray trace shadows do is they trace the path of the ray from the light source, and they're far more accurate than depth map shadows, although they tend to be more expensive, and they are hard-edged, which can be a good thing, but it can also be a bad thing. Not all shadows are hard-edged in the real world, and so ray trace shadows don't have the ability to have a soft shadow edge like depth maps do. So if we look at what these look, we see this extremely hard edge, but they are more accurate. You can see that they're undulating out of every single corrugation in these little containers. So they're more accurate, more expensive, and they are always crisp and hard-edged. Now, fortunately, you do have another shadow type. If we look here, you have area shadows, and area shadows simulate a light cast from a source that has some area to it, so a source that is larger than an infinitesimally small point of light, like with ray trace shadows. Ray trace shadows come from this infinitely tiny little point, and that's why they're always crisp. That's kind of a CG perfection of a light source. But area shadows simulate shadows that come from a light of a discernible area. And so what those do is they allow you to have a combination between soft edge shadows and hard edge shadows. So if we close this and we make that area shadows. Now if you come down here, you look at the area shadows roll out here, and you have basic options. You can set it to be rectangle, a disc, a box, or a sphere, and that's going to change the way it operates and the look of it a little bit. And then the trick to it is to change the length and width. So my scene is pretty big here, so I'm going to make it fairly large, and what I'll do is I'm going to take this light and I'm going to duplicate it over so that I can have something to be able to see one of the really good parts about area shadows. So now if we render this, you can see the quality of these area shadows, where they are sharper near the contact point of the shadow and the object, the shadow casting object, and they get fuzzier as they move away. And that's a really great property of those area shadows. It's a very natural property. That's what most shadows do. So contrasted with ray trace shadows, where if I take that light and Omni and just change this to normal ray trace shadows, and I can clone this view over here so we can compare. Let me render it. So it's evenly sharp all the way, and then also contrasted with depth map shadows, or shadow map shadows, which are equally blurry all the way around. They're equally blurry here as here. These area shadows provide a very natural shadow. But you don't get something for nothing, and so these really nice shadows come at the expense of render time, of course. They are more expensive, and so if you find, if we get those shadows back up there again, now this is a decent quality area shadow, but it took far longer to render than either the pure ray trace shadow or the depth map shadow. And if you find that your shadows have too much sizzle or banding, or they're too low quality, you need to ensure that these numbers are all high enough: shadow integrity, shadow quality, and shadow spread. Shadow integrity is the initial number of rays sent. Shadow quality pertains to the number of rays in the penumbra or the soft region, and sample spread blurs those together. So the first thing to try to change is sample spread. If you take sample spread up some, it will blur these initial number of samples together, or these two sample regions together, and blur their sample patterns within each other. So it's the cheapest way to get a higher quality area shadow. But there's a lot of times when that isn't quite enough, so you need to increase these numbers. But be careful with increasing these numbers, because setting these numbers to, this isn't just 2 rays you're sending. 2 equals 5, actually. If you have it set to 2, it's actually equal to 5, strangely enough. And then if you have it more than 2, if this number, either one of these numbers is more than 2, it's a square. So if you set it to 5, it's actually 25 rays. So don't say, oh, I need 15 rays all of a sudden. Doesn't sound like a lot, but if we fire up calculator here and we do 15 times 15, we're actually shooting 225 rays as opposed to 25. So we're not just doing 10 more rays, we're doing 200 more rays if you go from 5 to 15. So these numbers are a little bit sensitive since they're squares. Try to get away, if you can, with just increasing sample spread. That will blur it a little bit more, but that may take out some of the details in very small areas. If that's true, then you can start increasing these numbers by really just 1 apiece until you get the result that you want.